Hi, we are Team 25 presenting our assignment 3, which is about the evaluation and content analysis for the TREC dataset. So in this assignment, for the first three tasks, we had to have Apache Tico and Solar, which we already did in the previous assignments. And the third part for the CCD data is already used in several tasks in which we will discuss later. So before jumping through task 4, here we just created an outline for different part of the assignment in the correct sequence. So on the left side you can choose whatever visualization you want, and on the right side you can see them. So here we also show the amount diversity of different file types that we used in this assignment. And so starting with task 4, in which we should identify the classification path from request to content. So for this task, we used the CCD data in which we had the keywords inserted for each file as the metadata on the header. And then we compared those keywords with the content extraction that we did with the NER tools to see how much correlated those keywords are with the content of each file. We decided to show the analysis of this part using a histogram bar chart. So we divided the whole files into 5 different bins, starting from 20%, which is talking about the files that have from 0 to 20% correlation between their keyword and the NER extraction. So most of the files had a good correlation for the keywords and also those web pages that were retrieved for them. And then on the left side you see the percentage of the files that we used for this task. For example, for the 60% correlation, which is the bar chart in the middle, it's showing that 45 of the files are sitting in this bin. So let's start with task 5.
In task 5, we were supposed to derive the file size diversity of the CCA data set. So let's begin with file size of individual MIME types. So let's select one MIME type, gzip. So here you can see that almost 81% of the files are between 10 KB and 100 KB, whereas at less than 17% is below 10 KB. Let's pick one more MIME type, PNG images. A little less than 50% of the files are around 10 KB to 100 KB, whereas the other half is almost less than 110 KB. So this is the file size. Let's see the file ratio when compared to the Solar index. Here you can see the Java archive is almost 25% of the Solar index, whereas the other MIME types are less than 1%. You can see QuickTime is the only one I think that has an index of little more than 1%. Otherwise all these files are almost 0. So that covers task 5. Let's pick up task 6. So that's concerned with parsing. So parsing covers metadata, content, and parser chain. So let's start with metadata. So let's pick one MIME type that we will focus on. It's gzip. So you can see over 40% of the gzip files have a metadata size of over 10 MB and below 100 MB, and you can see various other size distribution as well. This is a 10 KB and 100 KB, and this one is less than 10 KB, and this one is between 1 MB and 10 MB. So it's a varied distribution. So let's pick up HTML files. HTML files are like between 10 KB and 100 KB, more or less half of them. 1/4 of them are between 100 KB and 1 MB, whereas the second quarter is like below 10 KB. So this is the MIME size. And this, let's bring up the content size. Let's pick up the same MIME types, HTML. So you can see the content is predominant 100 KB and 1 MB. So the other things are like 10 KB and 100 KB, and this one is like below 10 KB. So let's pick up one more. Let's pick gzip again. Almost 3/4 of the files have a content size of more than 1 MB and less than 10 MB, whereas 20% of the files are between 100 KB and 1 MB. So this is the content size diversity in our data set. So let's take up the parser chain. So here we can pick, let's pick up an image. So PNG images, you can see there were 3 parsers called, and they are called equally. So you can say that each image was actually parsed by each of these parsers, the default parser, the image parser, and the Tesseract-OCR parser. Similarly, we can see that XML files were being parsed by default parser and then the feed parser, and since they're equal, each of the files were parsed by each of these parsers. So this is the parsing diversity in our data set. Let's move on to language. So let's consider the language diversity. So you can select a MIME type. I selected gzip. You can see almost 75% of the files are in Slovakian and 24% files are in Hungarian languages. So you can select one more. Let's see, Perl. It's 60% is in English, as you can expect that. 20% is in Romanian and 20% is in whatever language that is. And let's take a PNG. PNG is again almost 55% is in Slovakian and 35% is in Hungarian again. So this is the language diversity. Let's see the overall language diversity. So you can see Slovakian and Hungarian and Italian are predominant in this data set, whereas English is like little less than average, I suppose. So that's the overall language diversity. We can also see the hierarchy of the application. So see in application type, we have Atom XML, we have gzip, Java Archive, OrchidStream, TKO XML. We have a varied number of languages in this set. We have just one subtype in the audio type, and it has English and Hungarian and Italian, stuff like that. Text has like plain, MATLAB, Perl, and these have a number of languages. Video has a couple of subtypes and a lot of languages again. And now we have images, again lots of languages. So that's with the language dendrogram. Now we can move on to the word clouds. Let's start with the content. So you can see various suite ontologies have been pulled out from the content, and the bigger ones are like higher in number and they are more frequent, and the smaller physical quantities, maybe high pressure and emission inventory, is like low in number. Calibration and equilibrium state are very frequent. So we can see MIME type. Sorry, I selected the wrong one. Let's see metadata. So you can select, you can see content type, X passed by, resource name are very frequent, whereas the images, the metadata linked to images like TIFF, image length, and other encoding and compression are like less frequent. Compression lossless, these are less frequent, but these three are predominant: resource name, X passed by, and content type. So let's move on to languages. It's more or less similar to the earlier one: Italian, Hungarian, and Slovakian. And English, you can see it's almost average. So that's the word cloud in general. So we move on to the next task, NER.
So for the task 9, we actually used 4 different NER toolkits that was provided in the assignment for us. We had the NLTK, Core NLP, NER, and OpenNLP and Grabit. Grabit is also more related to the measurements. So we just provided a composite parser. In our composite parser, we just considered NLTK, Core NLP, and OpenNLP because measurements had nothing to do with those. Like the agreement was very low, so we decided to just assign NLTK, Core NLP, and the third one, the OpenNLP, for the composite parser. So here you can see that we have 2 different bar chart sets. One of them is for words, the other one is for the files. So here we see for the words, for example, you can see here that the $sign, which is the tag on the left side, has been detected by all of them. So for the core NLP, it has been detected 10 times. In the open NLP, it's 8 times. NLTK 9 times. And Grabit for the measurement has detected 1 time. And then lastly, our composite parser, which is based on the first 3, is showing 8, which is the maximum joint agreement between these 3 algorithms. And we can also jump to the files right now. So for the files on the left side, you see the index of the files is starting from 0 to, we had about like 100 files considered for this assignment because the running times was very high. So here, for example, for file 26, you can see that there are 15 NER detections for the core NLP. Open NLP is 17, NLTK is 19. The Grabit for the measurement has detected 2, and then finally our composite, which is based on those 3, is basically the 15, which is the maximum joint agreement between those 3 algorithms. And we implemented all these in a Java, which all the different algorithms were running together in our composite parser. So that's it about task 9. Let's move to task 10.
So in task 10, we were comparing the measurement diversity. So let's see as per MIME types. So let's pick up a MATLAB, for example. Here you can see there are centimeters. In this case, the max, min, and mean are equivalent. Here in meters, you have like 60 meters as the maximum, 1 meter as the minimum, and 46 point something as the mean. Here you can see AM and PM also represented as units. We can see one more MIME type. I suppose this was the only unit present, and it's, I think, just one occurrence. So again, mean, max, and minimum are equal. Let's take one more MIME type. So this has lots of units. So let's see decibels. 0 is the minimum, maximum it's like 60,000 something, and mean it's like 8. Centimeters, 9 maximum, mean 6, minimum 0. So you can see we have a number of units. Maybe we can take one more MIME type. Let's take MPEG. MPEG again has 1, so that's boring. Images has a lot of, so you can see feet, you can see centimeters, you can see, I don't know what these images stand for. MBs are common. So hours, miles, so you have number of units. Let's see the measurement diversity overall. So a huge number of units, degrees, million hectares, hours, square meters, kilometers, bytes, million kilometers, whatnot and whatnot. So these are the measurements overall. And let's see per type. So in this case, we have considered length to be the type. So we have meters, we have kilometers, we have feet. Let's see, we have miles, we have kilometers again, and we have inches. So every unit has a mean, max, and a minimum. And let's see, the maximum length was meters, and that was like 6,613 meters was the maximum. And you can see none of the lengths are actually below 0 because lengths can't be below 0. Let's pick up a domain. So we looked into the CSCI data structure and picked up a domain, and you can see as per the domain we got units in that domain itself, and again distribution of measurements domain wise. So these are the various various units: area, year, meters, pounds, megahertz, moons, watts, feet, degrees, and whatnot. So this was the measurement diversity as well. So we actually implemented one more dashboard that covers the banana dashboard. So we're gonna see this here. So this is the search query field, and these are the number of hits. currently they are less. Maybe I can increase the count by reducing the number of filters. So it's almost 1/4 of a million, and you can see all these MIME types. You can see one of all these MIME types, so we can select one of the MIME types, so that's image JPEG. And so these are the languages in that image. We can see what file sizes are the heaviest. We can select the range filters. We can select these are the metadata filters, this is the content, and this is the file size. Yeah, so that's the file size. So you can see it's, I think, not a number, maybe error in the query, but all these files are like 0, and this is almost 16,000, this is almost 40,000, and let's see, this is 8,000, and the file size, oops, I can remove this error, it's almost 62,000, and all these files are like very small number, but these have sizes. You can see the MIME size versus the file size, a huge amount. Basically this is the file size and this is the MIME size, and this is the heat map for that. So you can see -1 represents I couldn't parse the file, so this is the flag to tell me that I couldn't parse. Maybe the file was corrupt, or maybe something happened and I couldn't parse it. And here you can see the content size and the file size. Here was this was MIME size versus file size, and this is content versus file size. And these are, all the heat maps, so you can see it obeys a fashion. You can see the languages. This is dominant Slovakian, Hungarian as expected, and Italian the next. So these three are like the dominant ones. Again, file size, all the different file size in different ranges. In this we have like 10 top file size ranges, so these are the file size ranges, and here we have like the top 3 metadata sizes. So this is the banana dashboard for covering our entire dataset diversity. So with this we finish our homework 3. Thank you for listening and have a good day. Bye bye.